In 1996, the internet went from 100 websites to hundreds of thousands of websites. Everybody and their grandma was building a website for pretty much every use case you could think of. We even stopped reading newspaper like this. And if you wanted to be in the game, you needed to have a website. Then, in March of 2000, the internet bubble burst. And for many, that was the end of the internet. A small company in 2002 tries to launch AWS, but it doesn't go anywhere. They'll try again in a few years. But after all, it wasn't the end of the internet. In 2003, MySpace is being released, and it changes how we communicate with each other. Then in 2004, Facebook is being released, and it changes it again. And something extraordinary happens around 2007. Steve Jobs goes on stage and announces the iPhone. The iPhone, besides being a revolutionary device, it really started the mobile race for the rest of the world. Everybody was now using our digital applications, not through the web anymore, but with mobile. And if you wanted to be in the game, you needed to have a mobile application. At the same time, that small internet company that tried to launch AWS in 2002, they'll launch it again in 2006. But this time, it works. And everybody's wondering what on earth is the cloud and why there is a cloud in the internet. In 2013, Docker is being released, and it changes how we package applications. In 2014, Kubernetes is being released, and it changes how we run them. The world was transitioning to cloud native, and if you wanted to be in the game, you also needed to be cloud native yourself. Then in 2016, a paper called Attention is All You Need essentially revolutionizes natural language processing models like BERT or GPT. In 2020, in the middle of the pandemic, OpenAI releases GPT-3, and then later in 2023, they released GPT-4. It was the most powerful model for executing tasks, complex tasks, with just a few set of instructions. The AI revolution starts. NVIDIA becomes the most valuable company in the world, and today, like yesterday, if you want to be in the game, you need to build an AI native strategy. You see, AI is changing everything in the world. Imagine how our life will be revolutionized by AI everywhere. We're going to be able to provision AI employees in one click to be able to handle simple tasks. We're going to be able to fully revolutionize the movie industry. We don't have to wait for Christmas anymore. We don't have to wait for Hollywood to release our favorite movie. We can think of one, and AI is going to create one for us. Law firms will be revolutionized with AI. Many law firms will perhaps even disappear. Everything will change in transportation, in cybersecurity, in finance. AI will change everything. But in order for us to build AI, we need AI infrastructure. You see, whenever there is a platform shift, there is always connectivity that needs to be addressed. In the web era, we were connecting our browsers with our servers using load balancers. In the mobile era, we were connecting our mobile applications to our APIs using API management. In the cloud-native era, we were connecting microservices with other microservices using service mesh and ingress controllers. And in the AI era, we're connecting our AI applications with the LLMs that we're using through an AI gateway. And today, I am very excited to make one of the most exciting announcements on AI gateway technology that the world has ever seen. Kong was a precursor of AI infrastructure with our original AI gateway. And today, we made our AI gateway intelligent. It is a breakthrough in the industry, and it looks like this. It doesn't really look like this. We're going to be seeing it in just a minute. But by the way, this video was also generated using AI. So before we reveal these incredible advancements in AI gateway technology that we're releasing today, we need to ask ourselves, why do we even need an AI gateway? And there's really three things that we need to do whenever we build AI. First, we need to make sure that developers that are building those AI applications have the opportunity to easily benchmark and test the different models to make sure that the outcome is as good as it can be. Then, once they deploy their AI applications in production, we need to make sure that we enforce security, governance, observability on all of the AI traffic that we are generating. Otherwise, we're going to be blind, and we can't be blind when it comes to this type of usage. And then finally, whenever we do deploy these applications in productions and users start using our applications, we also want to make sure that AI is as fast as it can be, because the faster, the better user experiences we're going to be delivering. And today, we're not really anywhere close to a good state. Today, effectively, our developers are not as productive as they should be, and the organizations don't have any visibility on the AI traffic that's being generated. We are blind on top of that AI traffic. We have no clue what is going on. And as you can see, this also presents a security risk for the organization. So why do we need an AI gateway? We need an AI gateway because we can move both the developers to a more productive place and the organization to a place where they have control of that AI traffic. It is not possible to scale AI consumption across every team in the organization if we do not do this. It's like writing software on paper. It doesn't work, it's hard, and it does not scale. So you may be wondering, fine, but every LLM out there has an API. Why can't we just use an API management solution to then offer these governance capabilities, these productivity capabilities on top of AI? And the thing is, API gateways are good at many things, but one of them is not being very good at understanding our AI traffic. They don't know what is the meaning, the intent of that AI traffic, but they do something very well. And that is the ability to be able to create access tiers for controlling the usage of our APIs. Our models are becoming products. If they become products, they need a life cycle, like APIs. And we can leverage the best of both worlds by creating good access tiers and yet fully understand what the AI traffic is. And so here at Kong, we took our very good performant lightweight core that we're using today to build our API management solution and our ingress controller. And on top of this lightweight core, we decided to build AI gateway. So we're taking the best of both worlds, the ability to manage governance on AI with the ability to fully understand the AI traffic we're sending to it. And of course, because it's the same underlying technology, we can deploy it anywhere, and it can also be managed by our unified control plane, Connect, which at this point becomes a control plane for managing both the APIs we're building, but also the AI models that we're surfacing inside of the organization. And there's going to be a sprawl of those AI models. It's only going to increase over time. And y'all, we certified it. And so today, I am very excited to announce the newest version of our AI Gateway, AI Gateway 3.0, available GA today. And this one, it is with semantic intelligence built in. You got it right. The AI Gateway is intelligent. It understands what you are throwing at it to be able to provide interesting capabilities on top of your AI traffic. So before we start with looking at some of these features, we need to know that AI Gateway sits in between the AI applications that we're building and the LLM and vector DB technologies that we're using to power AI. And then on top of this, it provides a series of capabilities. What is semantic intelligence? It is the ability to understand the meaning of the prompts that we're sending to AI. These prompts are being translated into vectors that we can store in a vector database of choice. And by doing so, we can then compute the similarity of prompts that have the same meaning but use different words. Let's make an example. Let's assume that, for example, I'm asking AI, how long does it take to cook a steak? That's one prompt. And then a second prompt, how long does it take to cook a fillet? Well, these prompts have a very high similarity between each other. So semantically, they have the same meaning. But if I do ask the AI Gateway, if I send another prompt that has nothing to do with cooking a steak, in this example, well, this will have a low similarity, and the AI Gateway will fully recognize that. So why does this matter? We can harness this intelligence to provide the next generation capabilities on top of AI Gateway. And the first one is semantic caching. With semantic caching, we can semantically accelerate AI by understanding the prompts that are being sent through it. So whenever we receive lots of AI traffic, we can now generate embeddings, we can store them in a vector database, and then we can store the content in a cache store in such a way that our AI gets a lot faster and our user experiences get a lot better. By accelerating AI, we are delivering the best AI experience to our end users and to our customers. This is very, very important. Then the next thing that we're going to be presenting, it is what we call semantic prompt guard. This allows us to semantically secure our prompts from unintended behavior that the developers or the users may be sending to it. For example, this is an election year. We're going to be asking a series of political questions to AI, but we want to actually make sure that no political topic is being discussed in our technologies. So what do? Well, with Semantic Prompt Guard, we can set up rules such as we can block any political topic from being discussed in our systems. And when we do that, by the way, we don't have to update our applications. This happens on the infrastructure. If we send another prompt that has nothing to do with politics, although I know that some of you are opinionated on how to cook your steaks, this will go through and it will not be blocked. Semantic Prompt Guard allows us to set these rules inside of the infrastructure itself so they can be continuously updated over time without us having to update our applications or chase down the developers. It makes them more productive because now all of these ships out of the box in the underlying AI infrastructure. This essentially allows us to improve content moderation, to increase our brain safety, to make sure that the consumption of AI, it is always secure. But it doesn't end here. The AI models we're building are becoming products and we need a life cycle for them. There's going to be more fine-tuned models that we're releasing at any given point in time. There's going to be lots of these models created for pretty much every use case you could think of that our developers have to consume. And how do we connect the developers with all of these models that continuously gets updated? Well, we do that with advanced load balancing, which is a new capability of AI Gateway 3.8. We can implement 6 different load balancing algorithms inside of AI Gateway. The most common being, for example, blue-green deployments or canary releases, but also retries and failovers. For example, we may want to fine-tune a self-hosted model and run the self-hosted model first before failing over to the cloud in case there is some downtime. This improves the high availability of our AI traffic. There are 6 different load balancing algorithms, like I said. 5 of them are very easy to understand. We can go from round robin to weighted to the ones that are redirecting traffic to the models and the LLM providers that are least busy, that have the lowest usage, and so on and so forth. But there is a 6th one that is very interesting. And again, this is a breakthrough in the AI industry, and that is called semantic routing. You see, in an organization, the teams that are fine-tuning the AI models and the teams that are using those AI models may not be the same teams. We may have data teams continuously fine-tuning our models to make them better, and then the developers need to be able to use those models inside of their applications to deliver the best outcome. Now, the challenge is that as the number of AI models grows to hundreds, to thousands of models, it becomes very hard for the developers to keep track on what is the models that we need to use for a specific task. Well, with semantic routing, we fix that problem. We can fine-tune models for different purposes. For example, we can fine-tune a model for being very good at answering support questions, and we can fine-tune a model for being very good at answering sales questions. And based on the incoming prompt, we can semantically route the request to the model that's better fitted for that specific purpose, that has been fine-tuned for that purpose. Developers don't have to know in advance what the model is. It semantically and magically happens at runtime on the AI gateway itself. So 6 different load balancing algorithms that allow us to provide a whole new level of maturity when it comes to managing AI at scale. And this allows us to implement a life cycle for managing models, a life cycle for versioning them, releasing them, and decommissioning them, but also improving the high availability of our software. And it just doesn't end here. There is more to it. We're adding support for new LLMs. Today, with AI Gateway, you build once and you can use any LLM that we support out of the box without having to change your code. It just happens out of the box. And today, we're announcing support of AWS Bedrock and GCP Vertex in addition to all the other ones that we support. You have access to tens of thousands of models out of the box simply by using AI Gateway. That developer productivity is going to increase as a result of that. So how do we migrate to AI Gateway? We made sure that this is as easy as it can be. Today, our developers are going to be using vanilla SDKs or frameworks like LangChain to build AI agents and applications. And to transition from what they have today to using AI Gateway and all the new features we're releasing, it is a one line of change. We're pointing our SDKs to AI Gateway And by doing so, we're going to be getting access to all of the new features we're releasing today and all the other features that AI Gateway already has. So I would like to invite on stage Marino, who's going to show us a live presentation of this new version of AI Gateway. Welcome, Marino.
Thank you so much for having me on stage, Marco. I am super excited to be able to talk to you about the AI Gateway.
Now, if you look at this Python application here, I've got the OpenAI client. And the biggest difference between this application and the one on the right is that I've just applied my base URL, and that base URL points to my Kong AI gateway, which I've deployed in Connect using a cloud gateway. Now, I'm not going to show you a sample Python application because that's no fun. Let's go ahead and take a look at something called Insomnia, which in my opinion is every developer's best friend. Insomnia actually allows you to write your APIs, test them out, see the responses, and then tune them as you need to in the form of mocking and the ability to optimize them as needed. In my case, I have 4 different calls out to OpenAI. The first call is simply asking OpenAI to give me a hello world code in Python. And if I go ahead and send out the request, we can see how long it takes. And it's using the AI proxy to be able to route this request to OpenAI. It took about 1.9 seconds, and we see that the content prints out a hello statement, which is a hello world in the form of a print statement. Now, if we actually go to the second request here, I'm asking the LLM, what is an example of a hello world in Go? So let's go ahead and send that request in, and we'll see that it's going to take a bit of time to come out. Now, what's really cool is I've enabled something called the AI Semantic Cache plugin. The Semantic Cache plugin actually enables us to cache similar queries, and when those queries come in through a request, they're evaluated through the Kong AI Gateway to determine for its similarity. In this case, because this request that I asked for hello world in Go was different than my previous request, well, I got a completely different response. If I take a look at this other dev's query, could you provide me with a sample Python app for hello world? And if I go ahead and send that request, notice that it only took like less than half a second. It gave me the same response. It printed out a hello world. And if we actually go into the header section, notice that the X cache status says hit, which means that it went out to the vector database to pull out the response because the query that we sent out was similar to that first query. What's really cool about this is we're reducing our latency to be able to get that response, in addition to being able to optimize the performance. Now, what if we actually wanted to see this from the lens of Connect? Now, in Connect, we actually can come in here and deploy cloud gateways, like I said. So we have full visibility into what our cloud gateways can do. And then I can come into my plugins and I can see the different ones that I've deployed. You can come in here and deploy as many as you need to for the different needs that you have. I have my AI Semantic Cache plugin enabled, and we're going to go ahead and take a look at some metrics here. So in the first set of metrics, I'm actually looking at all the different requests that have been missed or hit. Whenever I see a miss, that means that I'm having to make a call out to the provider for a response. But whenever I see something like a request, that means, and there's one hit for that request, that means that I actually went to cache or the vector DB to be able to get that information or a response to a query that was similar to one previously. Now, if I refresh the screen here, I can see some more data because I'm making some more calls. Some of these calls aren't similar, so they're unique. And because of that, the AI Gateway can go ahead and evaluate and notice that it's not unique, and so there will be a cache miss. Additionally, if we wanted to go and take a look at the latency, we can see how long it takes for us to be able to send out a query to a provider and then get a response. That's the round trip time for us to get a response to whatever query we provided. Now, this is important because if we're trying to optimize for our application, the data that we need lives in here.
This is so easy to use. Your AI applications will never be the same with this new AI Gateway. This will empower your developers to build the best AI-enabled applications. I want you all to come to my session, and it's called Efficient Inference on Advanced Semantic Caching. And if you're interested to find out some more details about the AI Gateway, go check out Jack Tyso's session as well. Thank you, Marco, for having me on stage.
Thank you, Marino. What a great presentation, very compelling. The features that we are announcing today are in addition to all the other features that AI Gateway already provides. And because this is built on top of the same underlying runtime as Kong Gateway, you get access to all the other plugins, hundreds of them, that you can use since day one on AI Gateway. This makes Kong's AI Gateway the most capable AI Gateway technology in the world. And as a matter of fact, we are working with our customers to deploy their AI infrastructure in production to be able to catch this new wave of AI applications. You see, up until now, we discussed about software you can deploy in the organization. But what if you are a developer who does not want to deploy AI Gateway, and yet you want to use it? You want to take advantage of all of the acceleration capabilities and the semantic capabilities we announced without having to deploy it yourself. So for you, if you want to do that, we took a small subset of capabilities and we made them available in a new product offering called Insomnia AI Runner. This is an offering that's meant for developers that want to use semantic capabilities without deploying it themselves. And it's very straightforward. By generating an acceleration link, you can use this link inside of your AI applications to enable semantic caching out of the box. No infrastructure to run, no infrastructure to deploy. We built our AI runner on top of the underlying technologies that we already support at Kong. So the core of AI runner, which runs in Insomnia, is actually powered by the AI gateway we just announced, and that AI gateway runs on top of connected dedicated cloud gateways. And so let's look at a demo on how this works. In this demonstration, I have created a simple chat bot or chat application where we can ask any question, like describe San Francisco for me. And this application will then make a request to the underlying OpenAI. As you can see, it may take a few seconds, 3.6 seconds in this case. So we can go to the Insomnia AI Runner and choose the provider that we want to support and the similarity threshold to determine different prompts using different words, how similar they should be treated. And so by selecting that similarity threshold, we can then configure our semantic caching inside of the AI Runner. We generate a link, and then we copy and paste the link it generates inside of our application. One line of change, that's all that it's needed to support AI Runner. And once we do that, we can refresh our application and ask again another question. And once we ask again another question, we can see how the AI runner, on the first request, it will still have the same latency because it has to go and fetch that request from the LLM. But different words, same meaning, same prompt, it is going to be a lot quicker. In this case, it's going to be approximately 700, 800 milliseconds. Now imagine every AI application you're building being 5, 6, 7, 8, 10 times faster, how good that end user experience is going to be. Have you seen how easy it is to use Insomnia AI Runner? It's one click. So today, we looked at this new AI world that's becoming a new platform shift in our industry that we have to support to power the next generation internet. We looked at how Kong Gateway 3.0 can provide intelligence to our underlying AI infrastructure to modernize how we deploy our AI applications. And we looked at Insomnia AI Runner, the one-click experience for developers to accelerate our AI. To get started from here, you can either choose to deploy AI Gateway across any platform, cloud or self-hosted or Kubernetes, or you can choose to run the Insomnia AI Runner in one click. I hope that you are excited as I am about all of these new AI advancements.